Hey everyone, we're going to take a quick look at kinematics problem solving. So here I have a couple of questions that are from the physics classroom website, which is a fantastic website for reviewing the concepts that we need to learn in this course. So first of all, let's take a look at the key equations that we need to use in this section of the course. So first of all, we have acceleration is final velocity minus initial velocity over time. Our second equation was displacement is initial plus final velocity divided by 2 and then multiplied by time. Our third equation, in no particular order, was displacement is initial velocity plus time, multiplied by time, plus 1 half at squared. And then our final equation. So these are four different equations that we use as we're solving accelerated motion problems. So as we go through a problem, we need to look at a strategy. So some of the key things that we're looking at here in our process is, first of all, constructing a diagram so that you have some kind of a picture of what you need to do. And then you can identify given information and unknown information in terms of the variables, and then identify the equation. Once we identify the equation that we're going to use, we substitute our values and then solve the problem to get an answer. So let's take a look at the first problem here. And we've got I'm a hurrying is approaching a stoplight moving with a velocity of positive 30 meters per second. The light turns yellow. She applies the brakes and skids to a stop. If the acceleration is negative 8.00 meters per second squared, then determine the displacement of the car during the skidding process. So we could draw a quick diagram of this car moving from an initial velocity to a final velocity with acceleration in the negative direction. And so what they're asking for in this question is determine the displacement of the car. So the way I would do it then is I'd write a list of variables with displacement, initial velocity, final velocity, acceleration, and time. Our 5 accelerated motion variables. We know we need to find displacement. We're starting with an initial velocity of 30 meters per second, and then it says skids to a stop, so the final velocity is 0, with an acceleration rate of 8.00 meters per second squared. Now the time is not given, and it's not needed, because we can use an equation that addresses these four variables. So we see displacement, initial velocity, final velocity, and acceleration. This means that we can use this equation because it uses all of the variables that we need to address. However, the final velocity is really 0. So when we solve for displacement, we will isolate d, move the vi squared to the other side, and then divide by 2a since it was multiplied by displacement. So let's go ahead and put the initial velocity of 30 meters per second squared and divide that by 2 times the acceleration. Now we can see we have a negative that's divided by a negative, so we're going to have a positive answer. So the displacement is positive, and we'll turn on our calculators and say 30 squared divided by 2 and also divided by the negative 8. And so we get 56.25, and we'll just put that in 3 significant digits. So positive 56.3 meters, and there's our final answer. Let's take another look at a second problem here. This one will likely use different variables, so we'll get to use a different formula. So first of all, Ben Russian is waiting at a stoplight, so his initial velocity is 0. When it finally turns green, he accelerates from rest at a rate of 6 meters per second for a time of 4.10 seconds. Determine the displacement. So here we have to find the displacement, and we can sketch a little diagram if we like. And accelerates now in the positive direction, moving forward. So let's list our variables. And here, determine the displacement. The initial velocity is 0. The final velocity is not given. This time the acceleration here is positive. That's 6.00. And we have a time. So here, we're going to use the equation that uses these four variables, which is VIT plus 1/2 AT squared. So let's go ahead and eliminate this term because we don't have an initial velocity. So we just have 1/2 AT squared. So let's go 1/2 times the rate of acceleration times the time squared. Now let's get our calculators and we'll multiply that all the way through, and we'll see 50.43. So I'll put 50.4 meters with a positive sign showing the positive direction. So those are two examples of how we go through the process of solving kinematics problems with accelerated motion. Hope this helps.